Good, good.
Great. All right, it's 8 o'clock now, right? Okay. Patricia, how are you today? Good. No response? Okay, great. Okay, let's start. Regardless how many participants. So, time fly, right? We are today week 8, is it? All right, okay. I forgot to put my. So, we too far, huh? Okay. So, but we go according to my teaching plan, huh? No surprise. So we're going to talk about transportations as well as assignment problem today. The assignment is not your individual assignment. Huh? It's a method of decision making required assignment methods. So for transportations, we're going to talk about how to solve transportation problems by using Q&A window. We have discussed how to solve solving transportation problem by using Simplex Method. So today we'll talk about that. And then subsequently, maybe not today, but tomorrow, grouping for section 2, I think have done groupings. So tomorrow we'll talk about the result is here. Like you can see crossword mark, like if I click the button here, in fact, the result for test 1 is here, but I'm going to discuss tomorrow. And then we also need to solve like have agreements from you all. When we're going to have our second test. All right. So summary things go according to plan. That's good. So you must remember always, regardless what you're doing, you must plan. Without planning, you plan to fail. All right. Now let's start our chapter, which is chapter 8 today. Let me share the slides, and then I will click the record buttons. Once I click the record buttons, I'm going to I'm going to turn my camera off. The reason is I noticed that if I put my camera on, the size of the recorded video size, approximately is nearly doubles of the size that when the video is off, is it? Okay, so I'm going to do that now, not because I don't want you to see me. I got no problem. I'm an old man. I don't worry that how I look like. No, Chris? Not like Chris, that? Look like you're a youngster. Oh, you're very concerned, lah. For me, I got no concern, lah. Old man, why I need to concern about appearance? Okay, who else here? Almost 14. But it's okay, lah. I'll click the record button and then we'll start. It's 8:03 already. Anyone who stay at Selangor that's affected by the MCO 3.0? Anyone of you? Happen?
Yes.
Yeah. Huh? Then which part of Selangor that stay?
What Doctor?
Which area of the Selangor that you stay?
That I'm staying?
Where are you staying?
Bangi.
Bangi. All right.
Yes.
Okay. Anyone else that affected? Besides Danny?
Saya doktor.
Is it? Safira duduk dekat area mana?
Sepang.
Sepang. Okay. Semua affected lah. Okay. Last night a bit confused, right? Boleh tak boleh dining. Ada yang kata boleh, ada yang kata tak boleh kan? Okay. Okay, let's start record now. Then we will start. Okay, today we're going to talk about chapter 8B. Chapter 8B is we continue on transportation model, but for today Let me do the setting first. Okay, for today's, what we have done in chapter 8A or 8A was we learned how to solve the transportation model. We learned how to solve transportation model by using simplex method. So today we're going to solve. I'm going to share with you another method of solving a transportation model, whereby we're going to use in this module we're going to use computer software, and in this module we're going to use a software called QM window. So 8A is talking about solving transportation model by using simplex methods, and 8B today we're going to cover 8B and 8C. 8B today we're going to talk about how to solve transportation model by using QM window. All right. So let's see what is the next slide. Okay, so this is exactly what I explained to you earlier. Regardless the method that you use to solve the transportation model, ultimately there are the two outcome or two objective that we aim for. Number one, we want to know the transportation plan. Means what are the quantity that need to transport from supply to demand, and second, we want to know the transportation cost. So regardless which method that we use, ultimately the aim is the same, which is we want to find out the transportation plan and we want to find out the transportation cost. Okay, we have done simplex in chapter 8A. Today we'll talk about how to use QM window. We're going to use the same example. You must be very familiar with this example because this is the one that we use in chapter 3. Chapter 3, that's based on this example, we develop the linear programming for the transportation of the wheat. And then in chapter 8A, we solve the transportation model using simplex method. So today we're going to use the same example. So why we use the same example? Because by doing that, we can compare the result between simplex methods and QM window. Okay, so I'm not going to take you through the setting of this example because you should be very familiar with that. Chapter 3, we discussed. Chapter 8A, we also use the same example. All right. So this example basically is dealing with, even though I said I'm not going to elaborate, but I'm going to briefly recap. We're talking about sending a wave from a supply to a demand. Okay, and the second table here showing the cost of transportations. The first table here showing the quantity of the supply for each elevator, and also the demands from Chicago, St. Louis, and Cincinnati. All right, so this is a balanced model, 600 and 600, and we're going to solve this. We have solved this using simplex in the last chapter. So today we're going to solve this using QM window. All right. So, all right, I will, instead of showing you the slide, I think it's good for me to do it on the spot. I thought just want to open a file of QM window, but I think it's good for me we do it together using QM window. So I'm opening QM window now. Just bear with me. What appear on the screen now at this moment? QM window. Okay, so the steps is almost the same. You have to go to module. So the module listed or show you the list of functions that can be performed by QM window. There are numbers of functions that can be performed by QM window. And today we'll talk about transportation. So you just click on transportations. Nothing appear. Why? It's because we need to click another button called new. Yeah, new. When you click new, QA window prompt for a basic input. Example title. Title I can just type with transportation model, and it look alike. It look like the input columns or input box for product mix that we did it a couple of weeks back. But the only difference is when you're doing product mix, linear programming, when doing linear programming, the item that appear here is called for number of decision variable, number of constraint. But for transportation, you need to define the number of source and number of demand or destinations. Okay, so in the example that we discussed, how many source and how many destinations? Good morning, everyone. How many? 3 source, three destinations. Right. Okay. Great. So I will key in three. And definitely, as I mentioned earlier, the objective is to minimize the cost. All right. And then I just click OK. And this table will appear. Let me show both windows easy for me to key in the data. So there should be two tables appear on the screen now. Am I right? All right. That's great. This one kacau. Okay. All right. So this is the input box or input table for transportation model. By default, the source will be named as source 1, source 2, source 3, and destination will be destination 1, 2, 3. I strongly suggest you to replace the names that set in default by changing to the actual name. So why is because if not toward the end of the day, when I say toward the end of the day means when you have solved the linear programming model using QA window, you are not, without changing the name to the actual source and demand, it's quite difficult for you to interpret the answer. You might confuse what is source 1, source 2, and source 3. So what I'm going to do it quickly is I'm going to key in the source here. Kansas City. I didn't plan to do this. I thought I want to use my file that I have created a couple of years back. But it's okay, I think, to make you have better understanding. I will key it. As well as the destinations, I will change the actual names of the destination. Chicago. And then another one is all right. So next, what I'm going to do is perhaps I will just follow the table. I will key the supply followed by the demand. So the supply here basically for Kansas City, the supply here is 150. You all must check. I might key wrongly as well. So you all must don't just sit down there or maybe lay down. You must check, make sure the number key is correct. So what I'm doing now here basically is I key in the supply here. The next thing I will do is I will key in the demands. Demand for Chicago is 200, followed by 100, followed by 300. All right. The next thing that will key in is the cost here. You might notice that the format of this input table is quite similar to the simplex table that we use in the simplex method. So no surprise because the concepts that use in QM window to solve transportation model in fact is follow the simplex method that we use. Therefore, because we are using the same method, therefore the table will appear similar. In fact, it's the same. So those numbers here are going to replace by the cost, which is the second table here. So it's 6. Oops. Is 6 and then followed by 8. Please check for me. I might key in wrongly as well. 7. Anyone can make mistakes. Even a professor, a doctor also can make a mistake. Any mistake? No, right? The data is correct, right? Okay. So I key in all the data here. So the next thing I will do is I remember in Simplex Method. In Simplex Methods, there are 2 steps involved in Simplex Method. Step 1 is you develop the initial cost, and then step 2 is you're using stepping stone to optimize that. So, and initial cost, we talk about 3 methods. So we have to define initial cost method before we can go for optimization. That is on Simplex. The same thing applicable applies on the so-called QM window. You need to go to here, starting method. Can you see a wording starting method there? Beside click.
Yes, Doctor.
Thank you very much. So you have to select which methods that you would like to start with. So the 3 methods shown in the selection box there are the 3 that we learned. Northwest corner, minimum cost, and Vogel approximation method. So they are the 4 method lah. Any starting method, but no lah. To be decisive lah, we don't just let it go lah. Don't just let the system choose. We have to choose. So as I told you earlier, normally if there's no sort of preference given, the best is minimum cost. Okay, so I will choose minimum cost in this example because we are also using minimum cost as a method for developing initial cost in our chapter 8A. So to make it in line, I choose minimum cost. So I just click minimum cost. Okay, then done. Then what I'm going to do next is same as what you have done in linear programming. Click the solve button here. Solve. When the buttons, when you click the solve button there, then there are a couple of output table or output table appear. You can see this. We're going to discuss one by one later. So the first table here is called transportation shipment table. Okay, we're going to discuss later. And then you also can see there's another table that's showing the marginal cost or we call it opportunity cost or marginal cost. Then there also table showing the final solutions, and the red color is so-called the marginal cost. What is that? We're going to talk about it later. And then iteration table. What is this? I'm also going to take you through later. And any more table? Yeah, this table is so like showing the shipment quantity. As I told you earlier, the ultimate objective for transportation model is to identify the transportation plans and the cost itself. So basically, this table also showing the cost and also the plan. And what else? This is almost the same, but in different format, showing the plan itself from Kansas City, Chicago, then what's the quantity to ship, the cost per unit, and the shipping cost. Okay, so there are a couple of output window there. Okay, before we talk about the output, let's recap what we have done just now. That I supposedly just show you like this, but instead of showing the slides, I have did together with you. I've done it together with you, a real example there. So to start with solving transportation module in QM window, you have to go to modules and then go to transportation. We did that just now. Then click new, then you have to click new and then select the numbers of source and destinations. And in the meantime, if you want to keep the title, you can do that at that title box. And subsequently, key in the supply, demands, and the cost. Since we have three source and three demands. So I change the number here to 3. Then when I click the buttons, the box will appear. So I advise you to change the name of the source rather than using the name given by default. So in this case, we reflect the actual name of the city. Subsequently, then key in the supply and demand. I've done that, so I just recap quickly. I've done that earlier on. And don't forget to select the initial method, the starting method. So by clicking the box here, the pull down menu there, then in this case we select minimum cost, and just click the sub button, and number of output window will appear. All right. So these are the output window that you can find in QN window, output window. QN window, output window. Okay. Okay. So next, what I'm going to ask you is example. Example, this is table A, B, output A, B, C, not table, A, B, C, D, and E. If I want, as I told you earlier, the main objective of transformation model is identifying the plan and also the cost. So if I want to identify or propose the transportation plan, which output that I should refer to, that I could refer to, sorry, not I should, I could refer to transportation plan. Okay, any more? Any more? Any more? Only A. B, D, okay. Then C, no. C, there's no plan. C is a not. No. E can. But which E? E1 or E2? E1, E2, yes, E2. And then I will take you to later. How about B? Can I use B? Can. So you see, all the tables reflect the transportation plan in different format. Unlike mixed product linear programming, the different table. But in transportation model, in this case, basically, it's only showing you transportation plans and transportation cost. Okay, there's no other thing. No? There's no other thing. Sensitivity, no. Okay, there's all the table that I circle could be used to work out the transportation plan. Okay, if me perhaps to make my life easier, perhaps I will refer to D lah. Why? Because D give me a very clear cut answer. Deliver from Kansas City to Chicago 25 ton of wheat. Deliver from Kansas City to Cincinnati 125. Perhaps I will use this. But nothing wrong if you refer to the rest. The answer will be the same. So you can refer to any one of these. And then regardless which one you refer to, you will get the similar answer. Okay. We just check one or two. A, transport 25 ton of wheat from Kansas City to Chicago. The first table, yes, 25. The second table, very clear cut. It's written for you there. And then the third table is the same. Okay. All right. Clear? Clear? How about I ask for transportation cost? Which table you want to use? Transportation cost. Back to that one, baby. Transportation cost. Which one you want to use? D. D. Beside D? Any more? D and then? B. Okay. Any more? You have no call, right? You have no call. Can you use this A? No. 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 Oh, then you made a mistake. Because the cost is there. The cost is here. No, like the default QM window output is a bit funny. Right? So in fact, you can use this. You can use D as proposed by you. But if you use D, you're not able to get the total cost. D is showing the transportation cost for each of the transactions. From Kansas City to Chicago, how much? Okay, blah blah blah. Okay, then from Kansas City to Cincinnati, 1250. But D doesn't give you overall picture of the total cost. Not a big issue. People like you learn this mathematics for so many years. You should able to sum up or total up this, and then you will get the total cost. If choose D, don't choose E and C. There's no information of cost. You can choose B, but it means this will be not the one that I'm going to choose, because by doing this, I have to calculate again. So I can do 25 multiplied by 150. No, 25. 150, correct? 150. I know to multiply. I have to 150 plus 1250 plus 1925 plus this plus this. I get the total cost. You could choose this, but again you have to total up. Why don't you choose A? The total cost indicated there. You see? So in order to choose transportation cost, you see, the cost is there. 4525. Okay, if your screen is a bit small, you can't see effect on your right top, right top. Is it right side, right hand side, top corner there? I think there's a button for you to change the layout to full screen or whatever. Okay, so it's 4525. So you can get the cost there. 4525. All right. So the output that we get here, this is bigger. 4525, the cost is here. Let me change back to red color. I notice that red color is the only color that I can find my pointer easily. So this is a cost, and these are the plan. So this table perhaps is quite straightforward. Okay, and you can see, in fact, if you remember the solution that we developed in Simplex Method, or the optimum solution. This is the optimum solution that we developed in Simplex Method, and it's exactly the same that what's shown by QM window. Okay, so you see 25, 175. The only difference is the name of the destinations and sort. Okay, I call it ABC 1, 2, 3 in the Simplex. But the solution that developed using Simplex and QM window both are the same, as well as the cost. You can refer back to the slide that we discussed in chapter 8A. The cost for the transportation model that we calculated manually was 4525, which is exactly the same as what we calculated today. So they're the same. They're the same. All right. So perhaps I'm going to ask another question. Is there any alternate route? You might call it route, call it the route or whatever. So is there any alternative route? What does it mean by alternative route or alternate routing? Basically, is at this moment, based on this QM window output, you're going to propose this transportation plan. Okay. On top of this 6 plan or 6 transaction route, is there any route that I can use without changing the transportation cost? That's called alternate. Alternate is on top of this 5, can I use another route? I don't use any one of these. I use another route, and without have any impact on the total transportation cost. So if this question is asked, Which table that you want to refer to? Which table you think that you should refer to? Which tables? I didn't put the number. I said, oh, that table. So I don't know which table. So I must name the table first. Which one? Wait, I guess. We talk about this, we discussed this in chapter 8a, no? E, okay, E is correct. Beside E? But E, which one is it referring to? You want to refer to E1 or E2 again? I ask the same thing. I ask the same thing, then Chris, just answer the same, give the same answer, and then it's correct. E2. beside E2, there's one more. C, exactly. Exactly. E2 and C. What are these numbers? What are these numbers? The number in red color here, okay, in red color here, and also the number that appear here. This number we call it as opportunity cost or marginal cost. What is opportunity cost and marginal cost? You have done this doing stepping stone process, which is a very lengthy process. Like +1, -1, +1, -1. Ada batu, tak ada batu, boleh lompat, tak boleh lompat. We did it there. This is the one that we did. We have done it. We done in the first steps of the first the first model. We check what is marginal cost or opportunity cost is. Initial plan, I recap what we discussed in chapter 8a, Initial plan suggests this. But we start questioning this. We're saying that if I move one unit to one of these empty box, what does it mean empty box? Box with number is a plan for the transportation. If this is 25, means the plan suggests that ship 25 units from 1 to 8. If nothing appears, then means there's no plan allocated for this route. 1 to A, 1 don't send anything to A, 2 don't send anything to A. But we start questioning, if I move one unit to this empty cell, empty box, what is the impact on the total transportation cost? And this is what we did in QM window. In the end, we work out, if I move one unit to 1A here, it was solved, it was set. It means the transportation cost was set or reduced by $1 if I move one unit. So is it $1 here? Appear here. So the number here representing the marginal cost. The negative one here means if I move one unit to Kansas City to send one unit to Chicago, then the overall transportation cost is going to reduce by $1. Okay, that's the meaning of marginal cost or opportunity cost. So same thing happened to this, Omaha, Chicago. And here, Omaha and St. Louis, and also Des Moines and Cincinnati. Okay, so, but we're not going to defer to this, but this is not a final solution. This is not a final solution. So the second itinerary, iterations is similar to, there are two tables I show you. So the second table here, the second layout here basically is similar to another table. The only difference is the second table here without indicates the transportation plan, purely showing the marginal cost. Okay, these two tables are the same. The only difference is the first table here, this is called the first table. The first table here showing the marginal cost for the first and second iterations. But the second table is only showing the final marginal cost. So the second table here is also similar to the second optimization step that we have done. We have done this, and toward the end, we found that this is 0 and 1, 3, 4. 1, 3, 4. 0, 1, 3, 4. So this number representing the opportunity cost or margin cost that we calculated in stepping stone. Is it clear so far? Faham? Clear, okay. So, but even clear, but you not yet answer my question. Is there any alternative route? What, which is the route that could be the alternative? What is the definition of alternative route? Alternative route is route that beside the 5 plan that proposed here. Can I change to another route without have impact on the total cost? No impact on the cost. No impact on the cost means 0 impact. So which one is 0? This is the only 0. Am I right? I can't change from Kansas City to St. Louis. Why? Because if I change it, the cost will increase by $1. How about here? Omaha, I say Kansas City, okay. Omaha to St. Louis, the cost will increase by $3. I'm not going to do that. So the alternate route is refer to the marginal cost box that whereby marginal cost is 0, indicated that this is the alternate routing for the transfer model. Means if I start sending certain quantity from Omaha to Chicago, and I stop perhaps sending one of these original transportation plan, the cost remain unchanged. Why? Because 0. Therefore, the answer is yes, from Omaha to Chicago. Is it clear? Okay, clear, good. Relatively, this is easier than the mixed product linear programming. We're nearly done, but I'm waiting for you to ask me one question. Anyone want to ask me anything? Something related to chapter 3? Nobody want to challenge or to ask? I use the word challenge means I expect you to ask me something that related to chapter 3. Right? Anything you want to ask me? No. So you see that the way that we're doing, the way that we are using the linear QM window to set soft transformation model is very easy. Like you just need to key in, and the input table is the same. This is very easy. But why? Why? If this is so easy, why I make your life so difficult in chapter 3 by asking you to develop this? Remember, we developed this linear programming. Why you want to develop this? This is so lecture. This is so lengthy process and also relatively complicated that the way that we discuss in this morning, right? The way that we discuss this morning easy, right? The way that we discuss this morning easy, which is you just need to. Why is my mouse not working? You just need to click a few buttons. You see, click a few buttons. Then you key in the number there. Based on this, you key in the number there. You click the solve button. Then the answer will appear. Why? Why if this is so easy, why we bother to create linear programming? Why? Because I want to torture you, is it? Why you want to do this? I also can do this. Okay, never mind. Before you ask me why, before you answer me why, I can do this. I also can do this. You see, I just click create the linear programming model that you learned in chapter 5 using QM window. You should remember how to do that. But this time I have so many variables. 1, 2, 3, 4, 5, 6, 7, I have 9. I create this model. It's what you have done, what you have learned in the mixed mode, product mixed mode linear programming. But the example that we did in the class is we only have 2 variables. But now I can create this. I can do this. If you don't believe, you go back, you can click this again. You're going to do this, and at the end, you will get the same answer. You get the same answer, you see. 25 from Kansas City to Chicago, because we call it 1A, like 1A. And then 125, you will get the same answer. 125, 175. I can solve in this method. But which method is easier? Chris, which method is easier? This method or the previous method? Previous, this is a bit, and the cost is the same. But why? Why we need to do this? Why we still think that we need to do this? Whatever subject to mean is constraint. This is constraint. What type of constraint are these? What type of constraint are that? These are operation constraint, right? Why I say this is operation constraint is because these are the limitations in terms of the source and supply, the source and demand. This source or this factory is only can produce max this quantity, and the second source only have capacity to supply 175, and the third source is only capable to supply 275. So this operational constraint. In life, solving operation constraint is not so difficult. The difficulty is come along with something we call this type of constraint. What are these type of constraints? Omaha will only supply maximum 10 tons to Chicago. Someone in the company, due to certain reason, we don't know why, and make out this statement. And the problem is this someone is a boss saying that Cincinnati will only receive maximum 8 tons from Kansas City, don't receive more. So these are so-called what policy? What policy? Sorry, I don't. What constraint? What constraint? Policy, Narita, I told you what policy. So it's a policy constraint. Okay, just imagine. Policy constraint. If I use the method that we used earlier on, where am I going to key in my policy constraint? Can I key in my policy constraint here? Cannot. The first method of solving transportation model that's using QM window purely dealing with operational constraint. If you have a funny boss in your company, or this is recording, there's or you have a special requirement, perhaps environmental or safety requirement that you need to meet. Okay, because the driver is too tired, so you limit the number of shipment for a source to demand. But perhaps that's also policy, but it's not due to management, but due to safety, due to environmental. Okay, so that type of constraint you can't sort of integrate it to the model that we learned earlier on. No choice. You have to use the linear programming that you learned in linear programming. You have to solve the transportation problem using the linear programming method that you learned in chapter 5, the mixed product method. So example, you must be familiar with this tutorial. You have done this tutorial. This tutorial, those that highlighted in yellow, these are policy constraints. How many? Two policy constraints. That certain location don't accept maybe certain reason, quality records, or perhaps the relationship between these two plant and firm, the relationship is not so good, so they're not willing to take. This type of thing make makes the whole sort of like operation more complicated. Complicated. Therefore, you have to it becomes a policy constraint, and you have to solve this policy constraint. You have to solve transportation model that with policy constraint using a linear programming. Okay, using a linear programming. Okay, and that's the reason. I don't know whether it's section 1 or section 2. Someone asked me in chapter 3, asked me, Doctor, can I do since x2b, x4c is equal to 0? Someone asked me, I don't know which section, I can't remember. Then someone asked me, in this case, can I put this one, can I delete this one? Because I know this is 0. And I also know which one, x4c is 0. Can I delete this one? The answer that given to the student in WhatsApp was, I said, don't remove first. You will know why when you come to chapter 8. That's the reason, remove first. Because you need to key into the linear programming. All right. Okay. So, by saying so, I'm not going to show this. I don't need to show this because we have learned this in chapter 5. In case you need to do this, then you can use the same method chapter 5. Okay. Then this is a tutorials for what for this QM window. Okay. So okay, any questions for this chapter? Any? Yes. Ken, you have to transfer into dummy model first. Dummy model. We have done dummy model in chapter 8A, right? But okay, you go and try. The beautiful part of this create window is create window will generate for you. I don't want to tell you because you have one tutorial not yet done. If you know that easy, key the create window. I shouldn't tell you this. There's one tutorial that using dummy, right? I think. Okay lah, give you a chance. You go and key into QM window. You see what happens. Okay. Because I tried to find one slide. Oh, this one I put at the last. I thought, okay, then I can just show you. Another thing that we learned two methods, right? The first method was this is for extra information, extra additional. We learned two methods. The one is so-called we solve transportation model using transportation method, right? Transportation method in QA window, and then you also could use linear programming method. So transportation model only will give you two solutions: the plan and also the cost. But linear programming on top of plan, at which point you use linear programming? I was telling you that when there's a constraint that beyond operational constraint, what is operation constraint in transportation model? Operation constraint is the constraint on the supply and the constraint on the demand. If you have a constraint that beyond supply and demand, then you have to use linear programming. That is when you need to use. But on top of that, I want to share with you is if you use linear programming, there's another advantage. On top of plan and cost, there are other things that you can get it. You can solve like refer to example sensitivity. 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 Okay. So this is a cost. This is a cost. This is a cost. This is the transportation plan from 1 to A. 1 to A, right? 1 to A. Now it's 6. So next thing I want to ask you, what is 2 and 6? What is 2 and 6? Range, exactly, sensitivity range means at this point, you remember 2 and 6, 2 and 6, okay, 2 and 6, 2 and 6, in solution tutorial, okay. 2 and 6. Okay, where is the solution here? Yeah, 2 and 6, okay. So this is the transportation plan. This is the transportation plan. So the cost from 1 to 8 for Kansas City to Chicago, basically we call it here. At this moment is $6. At this moment is 6. Means, example, the transporter, my transporter that hantar dari Kansas City to Chicago ialah Chris. Chris dia ada logistik company ya. Chris dia ialah company yang saya engage untuk hantar daripada Kansas City ke Chicago. Okay ya. So if Chris increase the price from 6 to 6.1, means you're going to change the plan again. If any of the supplier, example sekarang siapa, any one of you, then you set up a new company, then you want to sort of take over Chris business lah. Lepas tu Danny datang jumpa saya, dia kata, Doctor, I also can offer to transport. This is with transport the material from Kansas City to Chicago. I can offer a cheaper price. Okay, so selagi Daniel offer between 2 to 6, right? I don't need to change the plan. No, it make my life easy. Tetapi kalau Danny dia offer 1.9, the plan is going to change again. So this type of information you only can get from linear programming. You're not able to get from the traditional transportation model. Faham tak? Faham? Okay, alright. So it's sama dengan itu lah. Okay. So there's one tutorial you need to do it. So we done this. Kalau tak ada masalah, then we go for the next chapter. Is it okay? Okay, sebelum saya continue lah, there's one thing you need to know lah. From week 1 until week 6, until week 7, in fact, until week 7, we learn the thing we learn is very practical. In fact, very practical. You can use, but we learn a very practical way in the sense that daripada chapter 1 to 8, or maybe 2 to 8, we learn how to solve the problem using computer software. Even though QM window is not the commercial software, but it's very similar. Normally, linear programming, normally decision-making software is integrated with MRP or SAP. Tetapi sebelum ini, week 1 to week 7, kita belajar how to solve computer, very practical. But from week 8, from chapter assignment problem onwards, assignments, forecasting, kita tinggal 4 saja. Lepas today, kita tinggal 3 chapter. Forecasting, queuing theory and decision analysis. We're going to use manual calculation. Sebenarnya, I want to tell you that sebenarnya ada dekat sini. If you want to try, you can try. Ada, semua ada. Assignment pun ada dah. Decision making pun ada. Forecasting pun ada. I might show you. I might lah. But we're going to focus more on manual calculation. Why? Chris, mengapa? Ini tak ada record kan? Tak ada record, bagus. Chris, why the subsequent chapter? Why subsequent chapter saya tak record tapi mesti record lah. Bahaya juga. Tak boleh cakap apa-apa. People like Chris also good on recording. No. So like this, very common sense lah, see. If from chapter 1 to chapter 11, saya semua ajar guna computer software, tak ajar manual calculation. Ni di end apa yang saya nak tanya dekat final? What am I going to ask in final? So that is education purpose. But it's good that you need to know the basic also. So kalau you dapat tangkap what point that I want to tell you, then it's good lah. If not, then that's it lah. Okay. So these are all calculation lah. Okay, let's start with assignment problem. What is assignment problem? Let me open the slide first. Belum open slide. Let's start cerita. Semalam saya ingat dia akan announce JP pun akan apa MCO, tapi sekali tak kan. Supply lah. Ada orang KL dekat sini. Ada siapa duduk kat KL?
Me, doctor.
You Hazel, is it?
Yes.
Oh, Hazel, your place very dangerous. Surrounded by all the red June, MCO June, but KL tak. Funny eh? Sorry lah. Jangan record eh. Okay, now I start recording lah. Kena cerita tentang yang Ismail ni cerita lah. Cerita American Science kan. Alright, so we go for the assignment problem. This assignment problem is nothing related to your group project or individual assignment. So it's a decision-making method that with the name of assignment problem. So what is this assignment problem? Assignment problem basically is similar to transportation, very similar. Tetapi, however, in the transportation model, okay, I'll draw the simple one. What appears on your slide now is assignment problem, right? Yes. Okay, in transportation model, you have supply, you have demand, and then here is the quantity of the item that you're going to transport from supply to demand. And this number here can be 0, and then can be, depend if the supply here is 100, the demand here is 80, we take the minimum, like, can be from 0 to 80, am I right? Am I right? The number here, okay, this is transportation. Transportation number dalam box ini boleh daripada 0 kepada 80. Why 80? Because 180, I take the smaller. Kenapa I take the smaller? Because I cannot put 100. If I send 100 from supply to demand, then it's over what demanded. Right? So I need to take a smaller number. Okay, now assignment. Assignment is almost the same as transportation, tetapi in assignment problem, basically the number here is only 1 unit, cannot be more than 1. Okay, example, I think I give you example better. Example, before I look into the slide. Example is your group project. Example, I give you a group project. This group project is in the slide, but it's in wording. Wording sometimes difficult to understand. So example, I give you a project that consists of 3 tasks. Task 1, task 2, and task 3. Example, I give you an instruction saying that, okay, each group consists of 3 members. So every group has 3 members, example. Okay. So you're going to assign each of the tasks to one of these students or member. Okay. And now you start asking the students. Now I start asking a student example. Or as a group leader, you start asking the student. Student 1, if you do task 1, how long for you to complete the task? You say, ini maybe 5 hari lah. If you do task 2 maybe 7 hari. If you do task 3, this one easy, maybe 2 hari. Okay, example. Then you're asking task 2, the number here is berapa hari diambil untuk siapkan setiap task. Okay, the time taken to complete each task by student 1. Then student 2 say, oh ini maybe 6, and this one maybe 9, and this one maybe also 2, example. And then this one is 5, 8, and then this one 3, example. Example. So the objective for me is I want to find at the end of day, student mana yang buat task 1, student mana yang buat task 2, which student is going to do task 3, in order I have the minimum lead time. boleh siapkan projek dalam masa yang the shortest. Okay, so this is the purpose of assignment, mean assigning a job. The number here normally can be time, can be cost, can be distance or whatever, which is we're going to go through this. So before I move to the next slide, do you have a basic idea what assignment problem refer to? Maksudnya assign kerja kepada, can be, in this case, it's assign the task 1, task 2, and task 3 of group project to the 3 members in the group. Because of that, that's why I'm saying that at the end of it, the solution will be 1. Example, at the end I say that, example, not I said that at the end of the solution suggests that assign this to this, assign this to this, assign this to this. Each one of these will only get one job. Student 1 do task 1, student 2 do task 3, student 3 do task 2. That's why I said the number here will be only 1, cannot be more than 1. Can be 0 or 1, that's it. So that is only different. Because of that, then the method used also will be different. Okay. Faham tak? What is assignment problem? Faham? Okay, good. Then next. Okay, this is a quick one where we are now. Sometimes you have to go through this. Kita dah siap semua lah. Yang penting linear programming, graphical analysis, test pun dah tanya. Tapi ramai yang tak dapat bezakan paksi X dengan Y, Hairan. Then subsequently, we also done linear programming on transportation. We done Simplex Method. Then QM window for this we done. And then we're now at assignment. One assignment done, then there are 3 chapters left. Forecasting, decision making, and queuing. Okay. Now, this slide, the content of this slide, I explained in the earlier slide. Similar to transportation, dia similar lah, very similar. Tetapi supply and each source demand hanya satu saja. Sebab apa? I assign one task to one individual lah, cannot be more than one lah. Dia ada balance, ada yang tak balance. However, in our module for assignment, we only talk about balance model lah. Okay. The method to solve assignment problem, there are 4 steps. So the easier way to explain the step is by doing example, by using example. So this is the example. This is an example. There will be 2 examples we're going to discuss. Consider the case as assign 3 jobs to 3 people ABC. Ini cost pula. Then indicate the cost of the assignment, cost. Maksudnya, example can be solved like ABC is my part-timer lah. Saya ada pekerja part-time ABC. Then this part-timer kalau pekerja A, I ask pekerja A, saya ada 3 kerja nak buat. Mungkin kerja apa? Cuci toilet. Okay. Lepas tu, potong rambut. Lepas tu, job jack apa? Cuci cawan. Whatever lah. Okay, cuci dapur lah, cuci dapur. I got 3 jobs. I want to find a part-timer. So to do 3 different jobs, not one part-timer do all the job. I only going to assign one of them. So part-timer A saying that, okay, if I do job X, you will need to pay me $16. If I do job Y, then I think I'm going to charge you 20. You only ask me to do job Z, then Z, then it's 30. B sama lah, kalau B buat kerja X, then bayar 25, if Y 18 and B buat kerja Z, bayar dia 16. Faham tak scenario soalan ini? Faham lah? Okay, good. Then what we're going to do is, yang lain semua faham lah, besides Chris. The rest okay ya?
Faham doktor.
Okay, so you perlu faham soalan sebelum kita cerita how to do it lah. So you want to propose how the job should be assigned. Maksudnya in the end, part-timer A, you nak suruh dia buat kerja apa? B buat apa? C buat apa? Okay, dia tak boleh bertindih dah. Seorang dapat satu kerja saja, dia tak boleh bertindih. Alright, so now to do this, not only to do this, to solve assignment problem involve 4 steps. Step 1, step 2, 3, and 4. Lengthy. There are few keywords that you need to solve. Like you need to know now. Like. If you read 10 times, you also won't understand now. But there are few keywords that you need to know now. I will circle the keywords now. At the end of the day, when you finish the chapter, you've done the tutorial, you should understand all. But now, as a starting, you need to know that the first step is to calculate something called raw opportunity cost. Apa ini? What is it letter? Tak apa. You must know the first step is row opportunity cost. The second step is column opportunity cost. Oh, the third step lagi senang. The third step what you need to do is to draw minimum horizontal and vertical line. Draw line saja that cover the zero. Okay. Draw line lah. Step 3, draw line. Dah cukup. Yang ni tak faham tak apa lah. Step 1, row opportunity cost. Step 2, column opportunity cost. Step 3, draw the line. Then do some testing. What the testing? To see whether the line that you draw is it same as the number of row and column. If yes, stop. If not, then go to step 4. Okay. We're going to do 2 examples. The first can be resolved until step 3. Then we look at another example how to do step 4. Okay. So remember, step 1 is row opportunity cost. Step 2, column opportunity cost. Step 3, draw the line. Okay. Now, what is row opportunity cost? What is row opportunity cost? Row opportunity cost saying that first thing, identify the smaller number in each row. Okay, langkah pertama untuk step pertama, identify the smaller number of each row. Okay, ini row kan? Row pertama, which number is the smallest? 13, exactly. Second row, lamanya ambil masa ini. Kalau tak tahu, panggil adik you yang dekat kindergarten datang tolong you. Which one? 17, you did recording, sorry. So 13, 16, and 17. So basically, saya dah siap. The first step, then sub-step number 1. Langkah pertama, calculate row opportunity cost. Kan? For you to calculate row opportunity cost, the first step is identify the smaller number of each row. Dah kan? 13, 16, 17. The second step is every single number in the row subtract. Subtract maksudnya tolak lah. Setiap number ini tolak by the smaller number. Mean 16 tolak 13 dapat berapa? 3. 20 tolak 13? Minus 13. And then 13, 0. Do the same thing for the second row. 25 minus 16? Okay. 18 minus 16? And then this one, 0. Okay, we'll do quicker. Normally, the smaller one will do it last. If I cancel it now, perhaps will be, normally I do it last. You can't see the 17. So 22 minus 17. This one. And here 0. Okay, I done the first step. Recap, the first step is identify the smaller number each row. Subtract, calculate row opportunity cost, mean row subtraction. Subtract the smaller number from each number in the row. Okay, dah kan? Dah. So tengok betul lah. 390. Betul lah. Okay. Then the second step, you do it the same thing. You do the same thing. We do the same thing, but now instead of row, apa second step? First step is row, right? Second step, column. Just now I do it row, now I do column. What is the smaller number in this column? How about this column? And then these two columns. All right. So I've done the sub-step for step 2. So I identify the smaller number of each column, which is 0, 2, and 0, 0. Then I subtract the smaller number from every number in the column. Ini tak payah buat sebab 3 tolak kosong, 3. 9 tolak kosong, 9. But I need to do this. 7 minus 2, 5 minus 2. Dah, okay ya. See, is it correct? Betul kan? Sama kan? Okay, dah siap. Now, ini siap kan? Okay, now langkah ketiga. Langkah ketiga perlu berhati-hati. The keyword here now is minimum number. I'm going to draw line. Saya akan buat line. Line itu hanya boleh horizontal dengan vertical. Horizontal dengan vertical. Dan the line that I'm going to draw must be the minimum number of line. Dan lepas saya dah draw, saya akan calculate berapa garisan yang saya dah draw. Okay, I'm going to calculate. Langkah pertama, I draw the minimum line that cover, tutup kosong. Saya draw line untuk tutup kosong. Lepas itu, saya hanya boleh draw horizontal vertical line. Lepas saya dah draw, I going to calculate how many line that I draw. If the number of line that I draw is equal to number of column and row, number and column or row mesti sama. Sebab apa? Tadi saya ada cerita, we're going to use balance model. We're going to study only balance model. In balance model, kalau column 3, row must be 3. In this case, kalau column 4, row must be 4. So, garisan yang saya dah buat ini, kalau sama dengan the number of row and column, untuk case ini, kalau saya memerlukan 3 garisan untuk tutup semua kosong, maksudnya solution ini dah optimal. Is it clear? Is it clear? The difficulty, or not difficulty, not so difficult lah. You start to learn how to draw line before kindergarten lah. Drawing line is not difficult. The difficulty is how to make sure that you draw the minimum line to cover 0. Example, to cover 0, I can draw this way. 1, cover this 0, cover 0, cover 0. Hey, I draw 3 lines to cover the 0. Is it the minimum line? Yeah, but maybe not. Maybe not. So there's a way. I will elaborate this more when I come to the next example, because this example, not definitely you can see the problem. This method that I did just now wrong. Not this method. You cannot use this method. You have to use this method that I'm going to show you in the next couple of seconds. You have to do this first before you draw the line to make sure that, again, like an old man repeated many times, you have to make sure there's minimum. How to make sure minimum? You kira berapa zero dekat setiap row dengan column. How many zero in this row? 1. How many zero in the second row? 2. How many zero here? 1. How many zero here? 1, 1, 2. Okay, so row number 2 and column number 3 have the highest number of 0, and these two numbers are the same, right? Dual. So I draw these 2 lines first. Okay, tinggal satu kan? Ini dah jadi tak ada, tinggal satu. So I draw another line here. I can draw this line here, or I can draw this line there. Oh, ini tinggal ini sini aja. I can draw this and I can draw that. Now, berapa line yang saya dah draw? Berapa line yang saya draw? 3, right? So the number of lines I draw is 3. which is equal to the row and column. So my solution optimally, I don't need to go for step sort. I don't need to go for step sort. Okay, again, not necessarily I must draw here. I could draw this way. It's also tree line. Okay, yeah. So solution is optimum. Okay, solution is optimum because the number of column and the number of line is the same. But what solution is that? If the solution is optimum, then what solutions? What solution is that? Those that in zero means is the solutions. Okay, you see, A, you can assign job Z to A. You can assign Y and Z, Y or Z to B. You can assign X to C. Maksudnya A ada satu kerja yang dia boleh buat. Z. B ada dua kerja. A ada satu kerja yang dia boleh buat, 1-0. B ada dua kerja yang dia boleh buat. C ada satu kerja. Always assign yang hanya boleh buat satu kerja dulu. Siapa yang boleh buat satu kerja, assign pada dia dulu. So, A, B, C. Sebab B dia ada dua kerja kemudian. So, A hanya satu kerja boleh buat. Sebab kalau you tak assign dia, kalau you tak assign A, job Z, nanti dia tak ada kerja. So, assign A to buat kerja Z. Dan yang ini, C pun satu kerja saja dia boleh buat. X, must assign X to C. If you don't assign X to C, nanti C tak ada kerja. So, assign. So, ini dah tak ada, Z dah tak ada. Sebab Z saya ada assign pada A. So, C saya assign job X. So, the only thing left is Y, B. So, B, what? Y. Faham sampai sini? Is it clear? Clear. Tapi belum siap. Sebab tadi ini dah starting. Sometimes, okay, sorry, because sometimes I'm aware that I change to Bahasa Malaysia. If international, your problem, you must alert me. Yeah? So, assignment problem is very similar to transportation problem. Therefore, the solution that expected is not the assignment plan only. This is the assignment. This is the assignment. But I also want to know the cost. I also want to know the cost. In order to know the cost, refer to the original table. Okay? So A, Z, B, Y, C, X, Z. Assign job C, X, B, Y, and Z sama lah. So, ini dengan ini lah. Okay. So, the solution is the same. But next thing is, I want to know the cost. You must refer to the original table. Because this is the cost. Ini yang harga yang kita perlu bayar. This is the cost that we need to pay ABC lah. So the cost is equal to 17 plus 18 plus 13, which is equal to 48 lah. So this is the assignment matrix or assignment solutions that with minimum cost. If you do believe that test another assignment, impossible that you will get lower than 48. Faham sampai sekarang? Yeah, okay. Now, 48 here. The first example is only demonstrated how to follow step 1 and step 2 and step 3 to solve the problem, and you're lucky that in this example, you're able to find the optimum solution in step 3. Jangan harap ini berlaku dekat final. Impossible. You have to do step 4. Or you need to record it. I already forgotten. So now we look at another example. And this example, I can tell you in advance that this example require you to go for 1, 2, 3 to 4. And this is the example. What is this example? Yes. The first example that not the previous, in the cover page of this slide, I give you an example of our group project and also the task, so the task and student, right? So in that example, we're focusing on minimize the time. Right? So assignment problem can use to minimize, to find the best combination to minimize the time. Tadi, the first example, bigger task, bigger student. And then the previous example here, we try to minimize the cost. This example is going to minimize the distance of traveling. What the scenario or the background of this assignment, the problem or the example is assign 4 team of officials to 4 games. This is the official that's there be 4 games. There be 4 games at 4 different places. After that, we have 4 officers that need to assign to one of these game sites. Okay, A can go to any one of these game sites. Can go to Raleigh, can go to Atlanta, can go to Dallas, can go to Clemson. But the number here representing the distance. You want A to travel from where he is now, or maybe perhaps his office or his house, perhaps most likely his house, to Raleigh, then the distance will be 210. Cannot be km, I think it should be mile. Okay. Then the distance, the traveling distance from the original place that or maybe A's office or house to Atlanta is 90 miles. So these are the distance that each of the officers need to travel from their location to the city that organize the games. All right. So what we intend to do here, we want to assign this official to each of the game site with the ultimate aim that in the end, the traveling distance will be minimum. Faham? Faham tak? Faham? Okay, good. Then now we start with the first step. What is the first step? Row. So what are you going to do on the row? Which one is the? So which one is the smallest? 90. Second one? 70. Then the third one? No, not 140, 105. And then? Forgive you because your sister and your younger sister and brother is not here, Indonesia, right? So you got nobody to ask. So the last one, 65. Okay, so we identify the smallest. So this is the smaller. The next thing we're going to do is we're going to subtract each of the number in the row by the smaller number. So 210 minus 90, what you will get? 120. This you will get 90. Is it? 90, right? Correct. Yeah, 70. And don't forget this one. Zero. About here, you get 30. I do it last, this one. This one. And then I do it last. 0. How about here? Yeah. Right. Yeah. All right, and then don't forget to change the 0. Yeah. Yeah. This line indicated that I do it too slow. Okay, so any one of you do understand what I've done? Okay, faham, ah? So we get this. So next, what would be the second step? Identify the minimum cost of each of the columns. So the first column, valid, which is the minimum cost? Here, 0 or 0. Like here, how about here? How about here, Clemson? Okay, so what I have done just now is the second step, step 2. I want to calculate the column opportunity cost. So I try to find the minimum cost. So those that highlighted those in red color, the text, the number in red color is the minimum. So I'm going to do the same thing. 125 minus 15. And then here, 0. I found this line appear means I write too slow. I must write faster. Then, so 0, I need to do this. Okay. How about here? Here? Okay, I get this. Now, I want to draw the minimum line. This is the one that, now I go to step 3, no? I want to draw the minimum line. The keyword minimum. You see, if you didn't follow minimum, the one I'm going to draw now, in the next couple of seconds, is something that you should not do. You should not do this. Example, if you do this way, want to cover 0, the objective to cover 0, you can do this. I can do this. 1, 2, 3, 4. Oh, I covered all the 0. I covered all the 0. Then I count. Sorry, not calculate, I count. 1, 2, 3, 4. Oh, the number of lines that I draw is equal to the number of column or optimum. No, mistake. You shouldn't do that because you didn't follow the rule of minimum. In order to make sure that the line that you draw is minimum line that require to cover the 0, you follow the steps that I explained to you earlier. This step also not in the book. 1, I have to speed up line. I have to speed up, if not, the line will be there. So what 1 means 1, 0. If you know you write, okay, no? You don't want to write this, it's okay. I just want to make sure that you understand what I'm doing. So this is 2, 3, 1, 1. So theoretically, I draw this one first. Because this is 4, I must draw first. Then followed by 3. I draw 3. Then 2 and 1, I draw this. 3 lines. 3 lines covered all the 0. So you must follow the method. I repeat, because every semester, sure there's someone that did wrongly. You see, I can draw differently, you know. Oh, I want to cover the 0. Okay, I draw this. Just now what I did was I draw all the vertical line. I can draw all the horizontal line. What line I'm drawing now? And the worst part is recording, is it? So if I draw this line, 1, 2, 3, I also covered all the 0. But the problem is this is not minimum. In order for you to comply with the instruction given at step 3, minimum, you have to make sure that the line is drawn, the minimum line is drawn. And then to make sure that minimum is drawn, the way that can think of is write the number here. You couldn't find this instruction in the book, I tell you. So this is the line, this is a method you can do. So back new, why back new? Because the number of line you draw is 3, the number of column is 4. So this is not an optimal solution. This is not optimal solutions. Therefore, I need to go to step 4. Step 4 is a bit complicated, but not so difficult. First, what the step 4 explain, or what the instruction given by step 4, number 1. Smaller number not covered by the line. What are the number that not covered by the line? 105, 15, 55 covered by line, yeah? Don't use 15. So there are 6 numbers that not covered by line, right? Am I right? Oh, this 6 number that not covered by line, which number is the smallest? Smallest. Which number is the smallest? 15, exactly. I think I write here 15. 15 is smaller. Huh? Okay, now subtract from all uncovered number. Mean all the uncovered number, there are 6 uncovered number. Huh? There are 6 uncovered number. I subtract all the number with the smaller number, which is 15. So 105 subtract 15, what I get? 55? Yeah? And then last, I do this 0. But this is not the end of step 4. Step 4 saying that number 1, find the smaller number. Number 2, subtract from the uncovered number. What is it? Why I write A and 2, A and B, and then C. 15, I add the number to the junction. From the 3 lines that you draw, can you see this? There is or there are junction there. You know what junction? Junction. Any junction there? You couldn't find the junction. Here, right? Junction, right? Junction, right? These 2 junctions. So add the 15 to the junction. I repeat. Look at how many uncovered number. There are 6 uncovered number. Number 1, 6 uncovered number. From the 6 uncovered number, find the smallest. And the smallest is 15. Next, subtract all the uncovered number by 15. We have done that just now. The last step. Add the 15 to the junction. 0, add 15. 0, add 15. So, done, step 4. And we repeat the test optimization, means we repeat the process of step 3, drawing the line. So before I go to the next slide, any one of you unclear of this step? Tak ada. Good morning, everyone. Clear? Okay, clear. So this is the one that we have done. Same. 90, 0, 55, 0. 90, 0, 55, 0, 0, 0, 15, 15. 40, 10, 0, 5. 0, 16, 10, 0. Okay, now I want to draw the line. So what I'm going to do? Use calculate the 0 to 2, 1, 2. Yeah? One, 1, 2. So I can draw that whatever that we do first. Am I right? So which one you prefer me to draw first? There are many ways I can draw here on the horizontal. There are many ways I can draw, but end up with the same. You want horizontal 2, then I follow the 2. I follow the 2. In the end, still 1, 0, and not yet cover. I can draw vertical, I can draw horizontal. I can draw vertical and horizontal. Example, I draw this. Hey. Show someone is laughing there by the live, especially Chris. So you will get 4 lines. You get 4 lines. Okay. Oh, I can do different way. 4 lines. This is 4 lines. Hopefully the standard answer different. The standard answer here. I can draw vertical. Good. 1, 2, 3, 4. You can draw many. Okay, I read this one. Okay, that's why I draw horizontal. I can draw vertical. As far as I follow the sequence of number, the good thing is now every single number is base 2. So I can follow this way. Hey. Okay. Oh, something wrong with my pen. Okay, it's back to normal. Okay, I can draw in this way. 0, 2, right? 2, and 2. And then this 0, I can draw horizontal, I can draw vertical. Regardless how you draw, you will still get 4. So I will show you 3 examples. You will get 4. So now, the good news is we have reached the optimum solution whereby the number of lines that I draw is 4 and the number of columns and row is also 4. So next will be, what is the optimum solutions? What should be the optimum solutions? You can follow the same methods that I showed you earlier on. A, there are 2 cities that I could assign to official A, not official A. A can be assigned to go to Atlanta, can go to Clemson. So there are 2. B, 2 possible city. C, 1. D, 2. So by saying so, I will assign A, B, C, D. Which one I should assign first? A, B, C, or D? Come on.
D.
C. Correct. Because C, based on the optimum solution, there's only 1 city that I could assign for C. If I didn't assign C to Darren, then basically there's no more city that can assign to. What happened to this? Okay, so next, how about example B? B, where you want me to assign to? Okay, here is no more. Okay, let's see no more. Atlanta, you want to base on location, you want to base on people here? Atlanta, okay, who you want to assign to Atlanta? Okay. You want to assign to B, okay, no problem. But normally we follow by the here, B, Atlanta. This is an indication that I'm explaining too slow. Atlanta. Nothing wrong, no? Means, Atlanta. You see, Atlanta, I can assign to A, I can assign to B. Or B can go for Lalit or Atlanta. Okay, now we start with Atlanta. Lah. Okay, no problem. Okay, you just go for Atlanta. Done. If Atlanta had been assigned to B, then make sure we must go for A first. Because A initially have two locations to go, like now become one. Because Atlanta had been assigned to B, right? Correct? So A you have to assign to N. The only thing left is D. You have to assign to okay. This is one. I started with C and then Chris proposed me to go B for Atlanta. How about I do it different way? I don't want to listen to Chris this time example. I use different color better. I use this color. Okay. So this color I couldn't see the pointer. I changed to another color. This color, okay, better. A, B, C, D. Okay, C I got no choice. I have to assign first because it's only one. Okay, C I will assign first. But the second one that I'm going to assign, I'm not going to follow what Chris proposed. If still Atlanta, I don't want to employ Atlanta. I assign B to go to Lalit. So here, and go to Lalit. Okay. I can also do this way. If Lalit had been assigned to B, okay, so here is no more. I must make sure that D I must assign to somewhere else. So D I assign to Clemson. Then Clemson no more. A assigned to Atlanta. So this is another option for the assignment. I can have two plans. I can have two plans. And these two plans will sort of like end up with a similar cost. We try to calculate the cost. So before we calculating the cost, anyone have problem on finalizing the assignment plan? Zero means you can assign two. Tak ada masalah. Then, sama lah. Exactly sama. Oh, okay, good. Sama. Okay, sama. Now, I want to find the cost. Again, finding the cost refer to original table. Original table, okay, we try to calculate the cost now. A to Clemson, how much? A to Clemson? Yeah. B Atlanta, B 70. C ini. D ini 80 is it? So total 300, 450. Then how about this? The second assignment plan that we work out when I'm not listening to what Chris proposed. A Atlanta 90. B 100 like. C here is it? Okay. D Clemson. There's 260, 50, 450 also, right? So you see, these two plans, you can follow either one of these, and the cost will be the same. So this is a so-called assignment. No doubt assignments you can also do in the QM window. Depends. Maybe one day I will show you. but the module itself, we're going to use manual calculation. Okay, stop recording. So the next would be the cost. Oh, not the cost. That's sorry. The distance. The distance. This is the distance, not cost. Not cost the same. The distance, the traveling distance for both assignments, allocation or assignment plan are the same. Not the cost. Now we have studied the distance itself. Okay, and this is your tutorial. This is your tutorial. This tutorial is talking about assigning operator to machine. Okay. So you can try that. Oh, what is the time now? Good. Hey, we've done. Oh, it's a good time control today. Rush. All right. So we've done this. We've done this. So what we're going to do on this Thursday, in fact, not very far, tomorrow. What we'll do tomorrow basically is to discuss the tutorial for, and depend. I might not going to do test review because there's still one student, maybe not for a section, need to do some retest because she was absent due to not feeling well, hospitalized. So the test will be different. Maybe I'm going to do the review after that, but I'm going to share with you the result tomorrow. Depend how. So we're going to discuss tutorial, but I think tutorial for 8A, there are 3 or 4, quite a number of tutorial need to discuss, see how things go. All right, so good, everything on track. Hopefully tomorrow we also can complete according to the plan. Then you will go for your mid-sem break. When you're back from mid-sem, then we're going to have the test. Then there are 3 more chapters to cover. Then we end. That's good. Let's go to attendance. Let me share further. Okay, fine, okay. Economic kehadiran. Section 2. Okay, go ahead. There's whoever that if not record, I can put my camera on. Whoever yang dah apa? Yang dah scan, kalau nak leave the class, then